Thanks for sending this through. Really nice to receive a nice drawing, even though it's by hand. It's lovely, and you've really got everything detailed quite well here. So to answer some of your questions, is the vapor barrier in the correct place? The vapor barrier should go to the bottom of the insulation, to the warm side of the insulation. So theoretically it should come around, down and across there and up. So no, it's not quite in the same place, in the right place. So that's, if you can do it, I would do that. If you can't do it, that will probably work, but that is the correct way. Next question you've asked is about putting another layer of OSB on the top here so that you can put hard items on the roof. And will it sweat underneath it? No, it won't sweat underneath it. For it to sweat, you have to have the correct conditions in place, and because you're keeping all the heat down here, this will all be very cold out here and have very little vapor, so no, it won't sweat at that particular point. The next question you've asked is taping the boards down here to make an airtight system. Well, your vapor barrier, which is going around, will make the airtight system. And to do that, you need to have a vapor barrier that is glued down as well, because you can't have a loose sheet, otherwise the whole thing will be floating. So if I take you across to the Visqueen website and you look at the different vapor barriers that they do, you'll see a lot of people are using this, which is wrong. I've even talked to Visqueen about it, and they just say, look, this is this is not the right thing. That's basically this kind of vapor check. It's the wrong. And if you look at the different values of it, this only comes to 260 milligrams, where this one is 530. And if you look here, this is class 2 or 3, and it tells you just there what you should be achieving. But we use this one, and you can see how high it is, how much vapor it controls. But mainly it's because, and that's that one down here on the right, mainly that's because it is sticky back. And if you're working out your vapor probabilities on a property, you have to take and assess everything. You have to assess the roof and all the walls. But as the walls have normally not been assessed, and we don't know what's going to happen with the vapor control on the other walls, we put this element in as high as we can and assume that whoever does any work to the other elements in the room are going to assess that this has got a high degree of vapor resistance in the roof. Now let's move on to that. So I would put the vapor barrier just there, and would I seal the joints on the OSB? And the answer is no, no need to. The next question you ask, do I think that this detailing is okay? I think this detailing is all lovely. I think you've worked it out really well. The main thing what you've done here is that you've locked this RSJ well away from any cold areas. Where this drops down at this particular point here, if you took that measurement across from there to there, if this outside was all to get really, really, really cold, this is not going to get cold. If this did get cold, if this was quite close to that area and this did get cold, that would transfer through and this would be cold at the bottom. That means that any moisture that's in the air, and this room, let's assume it's central heated and it's mid December outside and temperature is sort of around about 0 outside. If you've got a transfer which is called cold bridging into this could be quite cold here. You've got moist air which is moving around all of this area. It goes through the ceiling and it could condense onto the bottom of this depending on how much moisture is in the air. You've got to remember that dew points, or where you're going to get this condensation, is not so much a temperature measurement. It's it's to do with the different amount of moisture that you've got in the air and the different amount of cold areas where the water can, the vapor can turn into a liquid, and that is down to sort of 3 or 4 different factors: how much moisture is in the air, how cold the item it is that it's going to condense on, and how warm the area is inside. So you don't want to do that, and you're not doing it on this particular RSJ. And the same applies here, because you've got so much insulation above it. That's why warm roof construction is really, really good. Because you've got so much insulation above here, this lower area here is just not going to get cold enough that you are going to get condensation on the bottom of it. It's just such a robust design compared with cold roof. Another question you ask is filling all the joints when you're putting this together with foam. Should you or shouldn't you do it? Oh, do it, because you need to continue this. It's like a quilt. You want to continue that quilt right away across, and you don't want to have any breaks. That's why we fill everything with the foam. And the only other thing I would say then is the weakest point that you've got here is at this head point going across that fact, but you can't odds that. This is probably a structural point here to hold the outside. You just, there's not a lot you can do to get that any warmer at that particular point, but it's probably warmer than that point and that point, and if that's a door or a window, and that as well. So that's it. Really nice design. Thanks a lot for sending this through. If you need any more information, please give me a phone call or email me through. Bye bye.